Welcome to Math Master. This is Saritha. Today we are going to discuss concentric circles. So what are concentric circles? Concentric circles are nothing but circles which are having same center. Yes. See, if this is a circle with center C. With the same center, if I draw one more circle, if I draw one more circle with the same center, this we call it as a concentric circles. Means two or more circles are said to be concentric if they have same center. Means for this circle this is the center and for this circle also this is the center. Yes. So like this, how many circles can we draw with same center? Yes, I can draw circle like this. Yes, I can draw infinitely many circles with the same center. But what all they differ by? They all differ by, see, if this is the radius of the first circle, R1 is with radius R1. See, the second circle, this is with the radius R2. Yes, and if you see, this is the third circle with radius R3. Yes, what happens? Here, see, the first circle is of radius R1, the second circle is of radius R2, the third circle is of radius R3. So, these all circles have same center but differ by radius. So, by this what we can conclude? We can conclude that always concentric circles are just differ by radius. Yes, these are the two concentric circles. Yes, this is the center of the two circles. Now, if we draw a card of a larger circle, so this is the larger circle, right? So, if you draw chord of this larger circle in such a way that it must be a tangent to the smaller circle, means that line, whatever the chord we are drawing for the larger circle must touch the smaller circuit at only one point. So, if you draw a line like that, so this is a chord AB. Now this chord AB touching the smaller circle exactly at one point. So this will automatically tangent to the smaller circle. If the circles are arranged like this, then automatically this point of contact, this is the point of contact of a smaller circle, right? So this point of contact divide this AB chord into two equal parts. Means this AP is equal to PB. Means this point of contact bisecting the chord AB. And we know very well, if you join center of the circle to the point of contact, this will always perpendicular to the tangent of that circle. Yes. So now we can easily say that the point of contact of a smaller circle is always bisects the chord of a larger circle. Okay, this is the one property of when you take two concentric circles. Yes. Our next point is, see, I have considered one triangle ABC. Now I have drawn one incircle of the triangle. What is an incircle? A circle which touches all the sides of a triangle is called incircle of a triangle. Now I have drawn one incircle which touches all the sides of this triangle ABC. Now if this is the case, we can easily observe that AB minus BP, which is always equal to AC minus CP. P is equal to AC minus CP. This we have to prove by this triangle. Yes, you observe these vertex A and vertex B and vertex C. See, if you take a vertex B, this is an external point of a circle. isn't it? If this is the external point of a circle, we can draw two tangents from this external circles. That is BP and BQ are two tangents drawn from this external point B. So we know that these two length of these two tangents are equal, isn't it? So these two are equal. I can write BP is equal to BQ. Yes. And if you consider an external point C, so if you draw two tangents from this C, this CP and C are the two tangents drawn from an external point C. So we can conclude that this CP is equal to CR because these are two tangents drawn from an external point C. Yes, CP is equal to CR. And if you consider point A, and we can also draw two tangents from this point A. So those are AQ and AR. These are two tangents and these two are also equal. Yes, which is nothing but AQ is equal to AR. Now I have to prove that AB minus BP, which is equal to AC minus CP, means this side AB minus BP, which is equal to AC minus CP. Yes. So I have considered the left side term AB. See, this is the AB, right? This is AB and this BP. This BP is equal to BQ, right? So now I am replacing this BP with BQ. Now AB minus BQ. Now you observe this is AB, this is BQ. So AB minus BQ is nothing but AQ, isn't it? So now I can write this is equal to AQ. But we know very well AQ is equal to AR. Yes, this is AR. Now this AR we can write it as this AR. We can write it as AC minus CR, isn't it? So which is equal to AC minus CR. And we know that this CR is equal to CP, isn't it? So AC minus CP. So finally we have proved that this AB minus BP is equal to AC minus CP. Yes. Now we will discuss a theorem which is alternative segment theorem. Yes. So what it states that, see, if you have a circle, so this is a tangent of a circle and this point P is a point of contact of this circle. Yes, if you draw a chord to this circle with point of contact. So means from this point if you draw a chord of this circle. This is a chord of a circle. Yes, if we draw a chord of a circle with the point of contact. Now here this chord makes an angle x degrees with this tangent. Yes, this is an angle made by this chord with the tangent. So this is the tangent and it is this chord is making an angle with the tangent x degrees. If the same chord, see, because of this chord, this circle is dividing into two segments. This is one segment, this is another segment. So this is the angle in this segment, isn't it? Now if this chord makes an angle in another segment, suppose, means if you join end points of the chord at any other point on the circle, means this is the angle made by the same chord in another segment. See, this is the angle made by this chord only, but with the tangent. And this is the angle made by the same chord in another segment, isn't it? And these two angles are equal. So this theorem states that a chord from the point of contact of a circle makes an angle with the tangent and the same chord makes an angle in any other segment of the circle, those two are equal. So this tells us that. So see, see this chord, if this is a PA chord, this PA chord makes an angle x degrees with this tangent. Yes. So this is equal to, and this angle made by the same chord in another segment of the circle. If this is B and this is an angle. So this angle and this angle, these both angles are equal. See, we have to see same situation in another way. See, if this is a circle and this is a point of contact, tangent, and this is the point of contact to P. Now suppose if I draw chord like this. This is also a chord. It is drawn from a point of contact to any other point on the circle A. Yes, this PA is a chord of this circle which is drawn from the point of contact. Now what we have said? We have said that this is an angle made by this chord with this tangent. Suppose if this angle is y degrees. Yes, and the same chord makes, this is one segment, this is another segment, and the same chord makes angle in another segment. Means if you join end points of this chord in another segment of a circle. So here an angle forms, and this angle is equal to y degrees only. See, you observe the cases. Sometimes in the given questions, they will give the figure like this or they may give like this. We have to identify that, yes, this represents an alternate segment theorem. So from that we can identify if this angle is given, you should identify that. So this is an angle made by the same chord. That is why this angle is also equal to the angle given. Yes. So and you can identify if the figure is given like this also. This also represents the same theorem. But the segment is here given like this. But the segment here is given like this. You have to identify. So the given figure represents an alternative segment theorem. Okay. So this we can write it as an angle APT, an angle APT which is equal to an angle PBA, angle PBA. Yes, and here an angle APT, an angle APT which is equal to an angle, if this is B, ABP, an angle ABP. So this is how we can define an alternative segment theorem. Our next theorem is converse of alternative segment theorem. See, in the alternative segment theorem, he has given that the line is a tangent to the circle and from that point of contact we have drawn one chord. So, but in the converse of alternative segment, what we have given that, so if this can be any line which is drawn from one end of the chord, means he has considered one chord. So, he has drawn one line at one end of the chord and that chord makes an angle at the another segment and with this line are equal. If the angles made by the same chord in another segment and with the line are equal, then line will become a tangent to the circle. Means in the first alternative segment theorem, he has given that the line is tangent to the circle at the first. But in the converse of the alternative segment theorem, we have concluded that means if the angles are equal, then the given line will become a tangent to the circle. Okay, this is the converse of a alternative segment theorem. Our next point is, see, if this is the given figure, means this is a tangent of this circle. This PT is nothing but a tangent to the circle and this PAB is a secant line given to the circle. Means when the tangent and secant line are given to the circle, what is the relation between them? Now we have to see. See, this PAB, because of this, if you join this point of contact to the point A and point of contact to the point B. See, this is a triangle. PTA is one triangle formed and PTB is another triangle formed. Now you observe the triangle PTA triangle and you observe PTB triangle. Now see the angle P in the triangle PTA, the angle P is equal to the angle P in the triangle PTB, isn't it? Because this is a common angle to both the triangles. Yes. So angle P in this triangle is equal to angle P because it is a common angle. And see, you observe the PTA. So angle PTA means angle at T. In this triangle, PTA triangle, this is the angle. So you observe here we are using alternative segment theorem. See, if this is a tangent, yes, this PT is a tangent and this AT is a chord of a circle. You observe this AT is a chord of a circle. This chord of a circle makes an angle. This is an angle made by this AT chord with the tangent PT. Yes, just now we have seen that if this chord makes an angle in the alternative segment, then automatically this angle and the angle in the alternative segment are equal. Just now we have seen. Yes. So you observe this is the AT chord and it is making an angle in the alternative segment, that is B. Yes. These two angles are equal, isn't it? Now angle PTA is equal to angle TBP. TBP. Yes. So this angle and this angle are equal because of alternative segment theorem. Yes. Now by this angle axiom we can say that yes, these two triangles are similar triangles. So what triangles are similar? The triangle PTA, which is similar to the triangle PBT. Yes. See, angle P is equal to angle P and angle T is equal to angle B and angle A is equal to automatically equal to angle T. Yes. Now, what happens if the two triangles are similar to each other? Then automatically sides are proportional. Yes. Now we can write it as PT by PB, which is equal to TA by BT, which is equal to PA by PT. Yes. Now I am equating these two, which is nothing but PT by PB, which is equal to PA by PT. So by this we can write it as PT into PT, which is nothing but PT square, which is equal to PA into PB. PA into PB. Now observe PT is nothing but tangent to the circle. Yes, means PT is, if you know the length of the tangent PT, so this PT square is equal to these, if these two are distinct, means this secant line PAB meets the circle in two distinct points A and B and this PA and PB are parts of that secant line. Yes, so if this PT square is equal to PA into PB. So this is the conclusion we can draw from this